on what we spend most of our time on. So we are
Wow.
basically a pigment dispersion company, and our bread and butter has always been the PU foam industry,
Wow.
and we make colors for PU foam industry. And today I'm going to highlight some of the recent developments that we have done in making some coloring solutions that makes the coloring much better for the PU foam industry in general. So before going ahead with what we do and explaining you more about the colors, I would like to start with a general topic. First of all, what is color? Why do we need color? What is color? I would like to introduce that to all of you. So color is basically, there is a sun god, as we call in our Hindu mythology. If I be bilingual, it will be okay, right? If I say in Hindi and English. So जैसे सूर्य भगवान है, so सूर्य भगवान ऊपर से white light भेजते हैं, उस light में already all the colors are there in that white light. So when that white light falls on a particular object, and that object absorbs a particular light and reflects the remaining light back. And when we see that object, our eyes perceives the remaining light that have been coming and just does not see the light that has been absorbed. And that particular light or that particular wavelength or frequency that has been absorbed by that particular object is what you called as the color of that particular object. So, for example, if all the lights are coming and an apple absorbs all the red light, absorbs only the red light and emits the remaining lights, so we will see the apple as red in color. Similarly, if an apple absorbs the green light, we see that it's a green apple. So that is what a color is. It is basically the wavelength or the frequency that has been absorbed by the particular object is what defines its color. So color has some perceived properties such as hue. Hue is basically the undertone of the particular color. When you see a black color, sometimes it is reddish in tint, sometimes it is bluish in tint. So that is hue. The colorfulness or the saturation, you all would have adjusted the settings of your TV and you would have increased the contrast. So that is what is the meaning of saturation. Then luminance. So how bright a particular color is, how it affects the surroundings around it, how brightens some like yellow color brightens everything around it. So it has a very high luminance, whereas a color like burgundy or a color like brown, it doesn't. So it has a low luminance. And fluorescence. So fluorescence is sometimes a color is a wavelength, a light is absorbed and it is then emitted a little later, and that gives you a very extra like a little extra effect. So that is what is called the fluorescence. So our as you can see this band, so this band is between 39, it's a band of the visible spectrum. It is called visible spectrum. So the visible spectrum consists of wavelength from 390 nanometer to 710 nanometer. And this is what our human eyes can see. So this is called the visible spectrum. And the color of an object depends on what it absorbs and what light it scatters. So each and every color is basically, if you consider the entire color spectrum as a globe, as a sphere. So each and every color can be identified with a color coordinate. So these color coordinate is called color values. So in this globe, we can like on Earth, if you get the coordinates of a particular spot, you can reach that spot. Similarly, each and every color value or color has a particular value, and we can reach that particular color by getting those values. So if you see here, if you see this particular globe, the white, so this L value stands for the vertical part. So the something which has L value high is white in color. Something which has a L value negative is black in color. Similarly, something that has a value plus is red in color. A value minus is green in color. and B value plus is yellow in color, B value minus is blue in color. So based on a particular color, let's say brown for an example. So where does this brown stands in the entire globe? Based on that coordinates, you can reach that. So this is called the CIE lab values, LAB values. And this is a system designed by CIE. So on the basis of that, we can get the coordinates of each and every color. So why is color required in slabstock foam industry? So as you all know, foam is naturally white in color, and foam is sold naked to the outside market, to the mattress industry, to the furniture industry, and many more industry in the sheet form or in the block form. So color is required to distinguish between different kind of foams. So that can that is this distinguishing can be on the basis of a lot of things. Like it can be on the basis of density. It can be on the basis of some properties, like it is an HR foam, it is a fire retardant foam, it is a lamination grade foam. What is the, like, is it a high price pure foam, or it is a filled foam, the commercial foam. It can be distinguished on the basis of cost, on the basis of application, like all the footwear or the industrial foams are mostly black in color. So based on that, color is required. And nowadays, since this foam is sold naked to the market, to the open market, the color is also used to create a brand identity in a particular segment. It also, foam is has a tendency to get yellow along with the sun exposure. It doesn't have such a good UV resistance. So color helps you hide that defect. It doesn't take away the UV yellowing property, but it helps you hide. So a white foam will look yellow much sooner, whereas a colored foam will not look so dirty or so yellow so soon. So it prolongs that shelf life. So what is our liquid colorant technology? So traditionally, when we started, colors were made in the form of pigment paste. So these were very high viscous color paste having high strength. And whoever wanted to use those color paste used to mix it with polyol before putting it into the color tank to make it meterable or pumpable. So in Chemie, what we have done is we are pigment dispersion experts, and we have worked for a very long time, and we wanted to achieve the same color strength while while making our colors completely liquid or completely pumpable. So that is what we have achieved. And how we have achieved that? So we have achieved by using some low viscosity polyols. We have used some special additives. We have some special manufacturing techniques and machines so that this liquid colorant stays safe, stable, consistent, and long lasting. So how is this viscosity? What is the right viscosity? What is liquid? What is pumpable? So we do it as per the final machine's pump requirements. So a lot of machines are already there into the market. So it can be a 𝐩𝐫𝐸𝐻, it can be a Ladderberg, it can be a AS machine, it can be Santec, it can be Indian manufacturers, it can be Chinese manufacturers. So based on the general pumping uh, values or viscosities of the pumps can handle, we have set the viscosity, so it is working on almost all the machines. So the colors are ready to use. There is no dilution required. These are high strength colors. These are not the pigment pastes diluted by polyol and then given to you being called as liquid colors. No, these are high strength colors, exactly the same strength as the color pastes, and these are not diluted with polyol. They are compatible with polyol though, and you can dilute it if you need to in order to achieve a very lower strength color or something like that. And these are liquid, flowable, and pumpable directly. So the basic idea was that to reduce your inventory as well. So we have some 6 primary colors and 1 black color that can be used to make many secondary color for your tanks. And it can work from on any machines that I already told, like 𝐻�0𝐻𝐸𝐻, Ladderberg, any machines it can work. And it can be customized to your machine and your color preferences as well. So here I have shown you the concept of 6 primary colors plus 1 black color. So these are some of the secondary shades that you can achieve by the combination. There are innumerable shades that you can make, but these are some of the shades. A lot of people that do come to us and tell us that we don't have so many color tanks for the primary. We have lesser tanks, we have 5 tanks, 4 tanks. So based on that, you can achieve that as well. Here we have only 5 primary colors. We have not included black in this, and we have achieved these many secondary shades. Then here we have only 4 primary tanks, 4 primary colors, and we have achieved these many secondary shades. So yes, the number of shades do limit and they do go down when you have lesser primary colors, but still you can create a lot of shades from this. And the more like the 6 primary colors, we can virtually achieve almost all the colors. And with lesser colors also, then also you can create your own secondary shades. So what is the difference between the liquid colorants and the polymeric colorants? So uh, our liquid colorants are basically liquid pigment dispersions, and our liquids are also liquid as what polymeric colorants are. There is no dilution required either in polymeric colorants or liquid colorants, though our liquid colorants are completely compatible with polyol and you can dilute it if you need to, but it doesn't require any dilution. Again, these primary colors can create secondary colors exactly the same. There is no bleeding in our liquid colorants as there is no bleeding in the primary colorants. I will come to this point and I will explain it to you in detail why there is no bleeding or migration in this. Then, yes, there is a little bit higher dosage that is required in our liquid colorants as compared to the polymeric colorants. And they can run on any specific pumps. They do not require any special precision high cost pumps. Viscosity of polymeric colorants is somewhere around 1000 CPS. So you have very lower bandwidth to play with a special kind of pumps in that. Whereas in our liquid colorants, it can run from in the pumps where the viscosity is between 1000 to 4000 CPS. They can be customized for your usage in whatever way it is needed, and the effective price that is being calculated on the basis of per kg consumption of color in foam, the liquid colorants comes out to be much cheaper as compared to the polymeric colorants that are available in the market. So here we will show you a small video where we have shown that there is no bleeding in our liquid colorants. So this is one of the sample of the polymeric colorant that is available already in the market, one of our competitor, and the other one is our uh, liquid colorant. So here you can see this is ethanol. So ethanol or methanol are generally used as solvent to check for the bleeding. So you take a fabric, white colored fabric, and put it on both of these foams, and you drop a little bit of methanol on top of it. If there is any bleeding, the color will dissolve into this solvent and come onto the fabric, and the fabric will turn blue. So this is what is supposed to happen if there is bleeding. If not, then the fabric will stay white. So then we have placed a glass plate and some weight on top of it. We wait for a while. And after a while, we will remove this weight. And here you see that there is no bleeding or no migration in the liquid colorants or in the polymer colorants. So why the bleeding or the migration concept, how it came into the being? So generally pigments, anything that is based on pigments, generally they never bleed. And what is the reason for that? The concept of bleeding came from dyes. So dyes are generally very, very small particle, and generally it is very, very soluble in a lot of material. So it doesn't when it goes into the matrix, if it receives any kind of solvent or any kind of water is also one of the solvent, it receives that, so it has a tendency to solubilize in that and come out. And even being smaller in particle size, it has a tendency to come out of the polymer matrix. Whereas pigment is an insoluble particle. It is much larger in size as compared to dye. So generally the pigment particle gets trapped into the polymer matrix because of some forces, and it is insoluble. So the solvent is not able to take it out from the polymer matrix. So the pigment stays binded inside inside the structure of the polymer matrix, and it doesn't come out. So anything that is made from pigment does not need to be polymeric. Still, it will not bleed. Whereas dyes, they need to be converted into polymeric so they don't bleed. So when you convert a dye into polymeric, then it adheres to the surface and it doesn't come out. So when we come to your plant, what are the details that we need from you to understand and to make the color suitable for your application? Generally, there are four types of pumps in the industry. There are millijectors, Hennike, Laderberg, and a lot of Indian machines. When I say Indian machines, the pumps that are used in the Indian machines are generally very, very similar. So that is why I've characterized them into one particular standard. And what matters for us? What are the questions that we are going to ask you? What is the minimum dosage you require, and what is the maximum dosage you require? So you need to have this particular thing, or what is the minimum dosage your pump can dose, and what is the maximum dosage your pump can dose. Second, we will determine the viscosity that your pump can dose. We will get to know your tank size. How big is your tank size? Generally, how big a foaming you do at one particular go? Are you able to consume the entire quantity, or you need more material? Things like that. What is the nozzle and pipelines like? What is the dosage that is required in your final foam application? Based on that, we will suggest you our liquid colorant, and our liquid colorant are compatible with all of the machines and all of the pumps. So why is viscosity so important? So viscosity is very, very important because viscosity is decided on the basis of pumps that your color tanks use. And if your color tank can use a particular viscosity, then only it is able to pump. Otherwise, you will get a metering alarm, or it won't pump so well, and you will have a lot of challenges. So it is always ideal to operate a pump from 20% of its capacity minimum to 80% of its capacity for best result. For example, if some pump has a capacity from 50 grams to 5 kilos, so it is ideal to go from say 100 grams to probably 4 kilos, like that. If some pump has a capacity of 500 grams to 5 kilos, then go from more like 70, 80, 700, 800 grams to 4 kilos or 4.5 kilos, and it will give you a better result. If you don't do that, then there are a lot of chances of air bubble coming into it, or the pump not metering properly, and there can be some streaking or waves into and issues like that can come. Indian machinery pumps, they operate between a viscosity of 500 to 5,000 CPS. So our colors generally are kept in the range of 1,000 to 4,000 CPS. So this is again 20 to 80, 20, 80, 20 rule we have taken here. So the colors are kept in between that based on your machines. For Hennike, Laderberg, and other machines not having millijector, this is also very similar. And for millijector, the viscosity requirement goes around 1,000 CPS. And how we are able to attain such viscosities, again, it depends on the selection of raw materials like pigment, polyols, and additives. And also depends on milling machines and media, and storage stability is very crucial. Why, when I say storage stability is very crucial, so when we say that a product has a shelf life of one particular year, it doesn't mean that the color is unusable after that 1 year. It means that after that 1 year, the viscosity of that particular liquid colorant will not be the same as it was when it was shipped from our company. It will change. It might increase, it might reduce, but it will be out of spec. So it is not so suitable to use anymore. So viscosity or the shelf life is very, very crucial. If we are able to offer you a shelf life of 1 year, that is a very good advantage in the liquid colorants. So here we have given you an example on what is the difference in dosages of our liquid colorants versus the polymeric colorants. As you can see, the yellow is somewhere around 4x, red is 2x, orange is 3x. So these are the standard polymeric colorants that are already available into the market. And we have not tried to match their colors, but we have tried to show the strength over here. Blue is somewhere around 2.25x. Black is apple to apple, 1:1. You can use it as it is. And violet is somewhere around 2.5x. But the best part about the difference between the polymeric and the liquid colorants, if you shift from polymeric to the liquid colorants from us, you can save from 20% to 50% based on the kind of color you shift from. So in some colors, there is a saving of around 20%. In some colors, there is even a saving of around 50% between polymeric and the liquid colorants. So this is what we are offering. We are offering you exactly all the advantages along with this kind of saving. So what are the advantages? Why you should shift on liquid colorants? There is no changes required on your machines. You start using these products with your existing setup without making any modification on your machines or pumps. There is no need for any shop floor mixing or dilution, because if your person is mixing it on the shop floor, some or the other mistake is bound to happen, and there is going to be settling if you're not able to finish that particular color in one particular go. It also eliminates spillage or contamination and labor work. So that is a big advantage. Everybody wants that the product should be plug and play. Like the moment it comes, it can be put into the tank and start being used. There is always color consistency because it is going from our company, so it is being checked. So the same thing is going to be used there. You are not dependent on your person to mix it with polyol on the same ratio. The ratio can go here and there, and you can have problems in color consistency. These kind of issues will not come. Then again, from primary shades, you can make multiple secondary shades. So it is less inventory. You can make shades like brown, burgundy, and these kind of shades you can make yourself. You need not disclose the formulation of these shades. You can create your own shades. You can change your own shades. You can create your own samples. So you are the boss. You don't need to ask anybody else for the formulations or anything. But in case you do need our support, we are always there. We are always there to give you a backend support. As and whenever you have any requirement, you will let us know the color you need. We will give you a combination immediately, and you can try the same combination at your machine. So that backend support is always available for you. The colors are customizable to your requirement. If you change a particular pump, if you change a particular tank, any pipeline, and you want the color viscosity to be changed or the strength to be changed according to that, that customizable option is always there. You have made a new color that has become your brand identity. You are using it in very high usage. You don't want to mix it on the machine for whatever reason. You say, I want a tailor-made shade that is only available to my company, and I want a tailor-made shade made from you, always match to my standard specification. We can do that. We can give you tailor-made shades, and it can be provided on demand. And the colors are very, very cost effective. What are the do's and don'ts while using the color? This is very important. If we go through this, probably we'll be able to eliminate a lot of problems that we encounter during our foaming due to color. So never keep the color can open, as the color can catch moisture, contamination, or dust or any foreign particles. These foreign particles can then go into the pumps and can create an abrasion or some kind of issues into the nozzle. So again, moisture, being water, is very, very sensitive. So you should not catch moisture. Always keep the color can sealed. Whatever you have used, just again seal the can. Always mix the color to make it homogeneous. So sometimes you make your own mixtures, you mix it with polyol, and there is a chance of phase separation. Whenever you open the can and you see a little bit of phase separation, please mix the color. You can use a stirrer, you can use a stick, or you can just put it inside your tank and recirculate for a while and remove the phase separation. Always bring the temperature of the color to room temperature or 25 degrees, so it is easily mixable in the polyol. So this point I want to explain it a little bit in more detail. So sometimes in North India during the winter time, people keep the inventory away from the temperature room. They keep it outside, and the color temperature, it goes down to probably 5 degrees, 7 degrees. And then when they see the viscosity, it do increases with the temperature. Viscosity affects a lot with temperature. And when you try to run these colors, it is not so easy for the pumps to pump this color. The output also changes with viscosity. So it is recommended to keep the temperature of the color at 25 degrees. The simple solution is, before foaming, whatever you need to use next day in the foaming, just put those color into the color tank, into the temperature room, and let the temperature come to the AC room, as per the AC room, to 25 degrees Celsius, and then put it into the tank. Always recirculate the color for 15 to 30 minutes to make it homogeneous in the tank before foaming. Whatever is stuck inside the pipelines will also come out. It will become homogeneous and it will give you much better consistency. Timely clean the pipelines and filters for any long-term sedimentation. Calibrate the color pumps with the same color. So generally the pumps are calibrated as per the polyol or as per anything else. So just try to calibrate the same tank with the same color pump. If it gives you the exact dosage, you will have the exact dosage, the exact output every time. It is recommended to install slow speed stirrers inside the color tank so the color can be easily homogenized. Try to put the color tank in the standard temperature room. This point I have already explained to you just now. And try to install the right pumps so you can dose the desired color quantity. And so sometimes the pumps that you have, like if you have multiple tanks and multiple pumps and you decide to use a particular color more or less, so you can change your tank and pipeline as per the pump capacity. Some color like yellows, they are not required in so much quantity. They can be used in the tanks that are used less. Whereas for the color like browns, for blacks, for blues, you need a lot of dosage of these color. So use it in the pumps where you have a higher dosage capacity, and do the right selection of the tank size so that you do not run out of the color during foaming. And this is a big problem. So sometimes people, they only do foaming as per their color tank. I have a color tank of 100 kilos. I will only do this particular foaming till I exhaust that 100 kilos, and they don't do it. But with the liquid colors, you have an added advantage. You can just pour the material over and top of that, and then keep on doing the foaming as well. So it is much, much easier for you to do a longer foaming with the liquid colorants. What are the factors that affect the color strength? So density is a big thing. The same color in lower density and in higher density, same PHR will look very, very different. So density does affect the color strength. Lower density will have a lower color, whereas higher density will have a higher color strength. Similarly, the percentage of filler inside, filler is white in color, it absorbs a little bit of color. So the more filler you will add into the foam, the lesser will be the color strength. So you have to increase the color strength if you want to maintain it as per the amount of filler you have. Again, polymeric polyol has a material called as SAN. It is a kind of a rubber, and it also is white in color and absorbs a little bit of color. So the more polymeric polyol you have in the system, the lesser will be the color intensity. So you have to adjust the color strength according to the polymer polyol added. Methylene chloride do reacts with color and reduces its intensity. So methylene chloride also affects the color. Secondly, the capacity of the pumps. I already explained this point to you in the last slide, that the capacity of pumps does affect. If you have smaller pumps, uh, you will not be able to dose at a very high dosage. If you have bigger pumps, which are not so precise, which have a very less low value, you will not be able to make very, very low intensity colors from that kind of pump. So capacity of pumps also affects the color strength. So identifying the quality of color, how how what all things are responsible for the quality of color? How can you identify whether a color is good or not? So the color should be homogeneous. There should not be any phase separation. If there is phase separation, please mix it before use. If you have diluted the color at your end for whatever reason, if there is phase separation, please mix it again. So the color has to be homogeneous before running. It should always be compatible with polyol. So if you are mixing it with polyol for whatever reason, it should stay compatible. It should stay like that in the tank. The particle size should be less than 10 micron. So that is how companies like us came into existence. We do not simply just mix the pigment powder along with polyol and give it to you. No, we micronize it, we grind it, and we bring the particle size less than 10 micron. This is essential because if you have a particle size above this particular limit, 10 micron, then the color will is going to destroy the foam cell structure. It is going to create a lot of pinholes. It is going to create some steel streaking or striation kind of effect on the foam. So the particle size of the color has to be less than 10 micron. Viscosity should always be consistent and in range, and colors should have high color strength. How can you check high color strength? Yes, you can check it on the machines, but there are a lot of factors that do affect the machines in terms of the pump output not calibrated or whatever. So whenever you want to check a particular color against its own standard and you have a doubt that this particular color batch is not as good as the previous one, just check and make a small box foam at your end of the previous batch or the standard batch and the new batch and get it checked whether it has the same color intensity or not. That being said, you should always maintain a master sample for your own use. Whatever you have used with any color supplier or any chemical supplier for the first time, you should preserve it and keep it as master sample for the shelf life and keep on replacing it so that that particular material you can check the current supply with that particular material. Color should have a shade that should be consistent. Its OH value should not be very high. And this is the reason if you have a very high hydroxyl value, the color is going to interfere into the PU reaction, or you have to take that particular hydroxyl value effect into your calculations. Generally, whatever colors we are supply has a lower OH value than 56, but 56 is the standard OH value of 3000 molecular weight. So we have a lower OH value than this. But if in case it is higher, then the supplier should share this information with the customers. The color should not have any fading. The color should not have any bleeding or migration. There should be even coloration throughout the block. If there is any scorching, if there is some yellowishness that is coming inside the foam, please once uh, check the foam without the color by making the same foam without the color and to check whether there is any scorching or not, to just find out whether it is a problem related to color or is it a problem related to the raw materials or to the formulation or the weather or whatever it is. And the color should always have low moisture content because water being one of the additives into the PU formulation acting as blowing agent can play with the density and TDI index. So color should have a very, very low moisture index, a moisture content. So what all testing you can do at your end to find that whether the color is similar or not. Again, what I said, master to batch box foam test. So it is a very simple. You all make box foams, but in the process you get lazy. You don't want to make box foam. You test it on the machine. That is fine. But whenever you have a doubt specifically on a particular color strength, please check it on the box foam along with the standard sample. If you find that it is not working properly, you can replace one or the other RM at a time to check what is reacting with the color. We have had one of this issue where at one particular customer we were facing very low strength in the black color, and we went there to solve the problem. We took all the raw materials from them, and the moment we changed their methylene chloride with our methylene chloride from what we were carrying from our lab, the problem was solved. And then the customer was able to identify that the methylene chloride he was buying was not the standard product, and he changed it, and the problem came back to the normal. So that also you can check in as a part of box foam. You can do a viscosity test. So this is a Brookfield viscometer, and we generally, whatever test report we give you, we mention the spindle number and we mention the RPM. You can check the Brookfield viscometer. I'm going to play this video just to show how we check the viscosity. So we have put the spindle number 5 over here, put the color sample, and we are going to start it. Now we don't take viscosity until and unless the readings become stable. So it started with 1300 CPS, but you wait for the reading to stabilize. Wait at least 30 seconds. And now the reading has stabilized at 1088 CPS. The reading was taken at spindle number 5 at an RPM of 50. So this two values, the spindle number and the RPM, is very, very important because the reading will change with each spindle and each RPM. So it has to be exactly the same as per the test report that we have given you. So you can find out that whether it is adhering to the test report or not. So this Brookfield viscometer should be there in each of our customers' end to identify the viscosity of the color. So again, PU foam being very, very susceptible to UV, and it does not have good UV properties. A lot of time people want that the color should stay there. It should not fade away. It should not change on prolonged exposure to the sun. So color do tend to change and fade or even degrade on continuous sun exposure. White foam never stays white. So we have UV additives with us as well. Even if it is not white color, it is for some other color, you can add the UV additive. So I would like to explain how the UV additives work. So UV additives are basically sacrificial products. So what does that mean? So the more you are going to add, it is going to stay inside the foam. When the UV light will come, it will start consuming and reacting the UV additive first. It will not do anything to the foam. It will only affect and consume the UV additive. So in a way, it is being consumed by the UV light. And once it is completely finished, then it will start affecting the foam exactly like it does without the UV additive. So it is a kind of sacrificial product. So the more UV additive you will put, the more life it will give to your foam. And it has a combination of chemicals that hinders the light photons, that prevents the foam degradation and act as antioxidant as well. So these are three different kind of chemicals that are mixed together to make UV additives. So this is it will help prolong the life of the foam. So wherever the color is required to stay like that for a long time in sun exposure, you can use UV additives. And if you need anything, you're more than welcome to contact us for the same. So we are dispersion experts. What other dispersions you can expect from us? We can also make you FR dispersions. So as a lot of you are already using TCPP or liquid FRs, we can combine them with graphite to give you pumpable, non-settling, even dosage product. It's a FR dispersion, so that is pumpable and it does not settle over time. So if you are going to make it at your own end, graphite will has a huge tendency to settle. It even settles during the foaming itself, but whatever we will give you will not settle over time. So we can make a stable dispersion and give it to you. So this is all from my side. Thank you. I'm Gaurav Sachdeva. I thank you to all of you for this wonderful audience for coming out here in record numbers. If you have any questions, you can contact me and I'm open. I'm opening the stage for any question and answers.
Thank you, Gaurav. Now, if anybody has any question, please feel free to ask. Yes, please.
Hello, Gaurav.
Hello.
Hello. Yeah, Gaurav. Tanvish this
Yes.
side.
Yes.
Yeah. Actually, Gaurav, myself Tanvish. I represent Colorina International. So I just
Okay.
want to know that in this liquid colorants, do you use the normal pigments or do you use the high performance pigments?
We use both actually. It depends from the formulation to formulation. Somewhere normal pigments are also good, and somewhere wherever it is needed, we are using high performance pigments as well. It depends on my customer's final application, what kind of application he wants to use it in.
Okay, like
Yes.
you have showed some of 5 to 6 primary colors to us,
Yes.
right? So in that, red was one of them, right? So
Yes.
for red, it was more darker. So for darkerness or something, you use high performance, and for the secondary colors, you use azo. Is it
No.
right?
No, no, no. It doesn't work like that. So darkness does not depend on any high performance or normal. Darkness depends, like some pigments perform better in foams, some pigments do not perform in foam at all. So wherever you need a lot better light fastness and better heat stability, you go for high performance pigments. So we use it as per the usage. If the customer needs much better light fastness and heat stability, then we go with high performance pigments.
Okay, okay. And is it glycol based?
Yes, the products are glycol based. Yes.
Okay. Okay, thank you, Gaurav. Thank you.
Thank you.
Yeah, next we have Soumya Ranjan. Over to you, Soumya.
Good afternoon, sir. Good afternoon, ma'am.
Good afternoon.
So my question was that the जब भी हम जो पेस्ट रहता है पेस्ट को पॉलियल के साथ मिक्स करके डालते हैं तो वो पॉलियल का अमाउंट हम टोटल पीपीजी के अमाउंट से माइनस करके चलाते हैं कि 100% हमारा पॉलियल रहे
Right.
फॉर्म में तो
Right.
ताकि जब हम रेडी टू यूज कलर जो यूज करते हैं उसमें क्या रेशियो रहता है जो हम एक्सपेक्ट करें कि माइनस कर सकें पॉलियल से
तो यहाँ पे हम रेडी टू यूज कलर जो बोल रहे हैं, मैं फिर से आपको थोड़ा सा स्पेसिफाई करना चाहूँगा। हम यहाँ पर वो पेस्ट को पॉलियोल से डाइल्यूट करके आपको रेडी टू यूज नहीं दे रहे हैं। यहाँ पर हम आपको पेस्ट ही कॉन्सेंट्रेटेड फॉर्म में जो होता है उसी को हमने लिक्विड में कन्वर्ट किया है। तो आपको जो कलर मिलेगा वो कम्प्लीटली लिक्विड फॉर्म में मिलेगा। सो देयर इज उसमें आपको आपकी इससे बेटर डोसेज आ सकती है, क्योंकि जब आप पॉलियोल से डाइल्यूट करते हो और आपका
जी
पंप की कैपेसिटी फॉर एग्जांपल 3 किलो चलाने की है, तो आप
जी
डाइल्यूट करते हो तो आप इफेक्टिवली 1.5 किलो से ऊपर कलर नहीं चला रहे हो, 1.5 किलो तो पॉलियोल ही चला रहे हो। बट इस
जी
केस
सर
में आपका जो कॉन्सेंट्रेट कलर है वही पतला है, तो आप इसको जब चलाओगे तो फुल कैपेसिटी तक आप भी जा सकते हो, आप हायर स्ट्रेंथ पे भी कलर चला सकते हो।
तो उससे हमारा डेंसिटी वेरिएशन तो हो सकता है
नहीं होएगा।
मान के चल
डेंसिटी
सकते
वेरिएशन कैसे होएगा?
जब 100% हम पॉलियल यूज करेंगे उसमें माइनस ना करके और
हम्म।
ऊपर से एक्स्ट्रा कलर ऐड करेंगे
हम्म।
तो डेंसिटी वेरिएशन हो सकता है क्या उसमें
डेंसिटी वेरिएशन कैसे होएगा ना, आपका जो कलर का जो आपका जैसे हम मैंने आपको स्पेसिफिकली बताया कि हमारा OH जो है वो बहुत कम रहता है। हमारा OH जनरली 20-30 के बीच में रहता है। तो उससे आपका फॉर्मुलेशन में इतना इफेक्ट नहीं आएगा, तो उसकी वजह से आपका कोई भी डेंसिटी वेरिएशन या इस तरीके की कोई प्रॉब्लम नहीं आएगा। आप अलग से पॉलियोल नहीं डाल रहे हैं ना?
ओके सर।
Yeah.
और एक क्वेश्चन था सर कि 10 माइक्रोन से नीचे का जो रहता है उसमें सेल वॉल डिस्ट्रॉय हो जाता है, जो माइक्रोन
10
रहता है।
माइक्रोन से अगर ऊपर है, मतलब अगर पार्टिकल साइज बड़ा है, 10 माइक्रोन एक इंडस्ट्री स्टैंडर्ड वैल्यू है, बट
जी।
टू बी एग्जैक्ट, अगर आपका पार्टिकल साइज बड़ा है तो आपकी फोम का जब सेल बन रहा है, न्यूक्लिएशन हो रहा है, उस टाइम पे बड़ा पार्टिकल साइज उस न्यूक्लिएशन को डिस्टर्ब करता है और फोम में पिन होल्स के प्रॉब्लम आ सकते हैं। तो ये प्रॉब्लम जनरली उन लोगों को आते हैं जो बहुत ही खराब क्वालिटी के पिगमेंट्स, पेस्ट्स, या फिर बहुत पुराने पेस्ट बने हुए हैं जो खराब हो गए हैं, एक्सपायर हो गए हैं, या डायरेक्टली पाउडर उठा के उसको मिक्स किया पॉलीऑल के साथ और ऐसे ही चला दिया। तो इस तरीके से ये इश्यूज आते हैं, और स्ट्रीकिंग के भी इश्यूज आ सकते हैं।
और एक था सर, एमसीएल कैसे इफेक्ट डालता है, जो कि आपने बोला था कि एमसीएल चेंज करने के बाद उनका प्रॉब्लम फिक्स हो गया था,
सो
तो
मेथिलीन
एमसीएल कैसे
क्लोराइड जो
इफेक्ट
होता
डालता
है
है?
ना, ये फॉर सम रीज़न कलर के साथ रिएक्ट करता है। और इसकी वजह से अगर हम MCl, जैसे अगर हम एक फॉर्मुलेशन बनाते हैं फॉर अ लो डेंसिटी विदाउट MCl एंड विद MCl, तो हमने ऐसा देखा है विद MCl कलर वैल्यू थोड़ी सी कम आती है, स्ट्रेंथ कम होता है। पर एक कस्टमर के यहाँ पर एक स्पेसिफिक बैच ऑफ MCl के खराब था या क्या था, अब उसकी केमिस्ट्री में तो मुझे नहीं इतना आइडिया, बट उसकी वजह से काफ़ी ज़्यादा डिफरेंस आ रहा था ब्लैक कलर में। तो जब हमने इसको आइडेंटिफाई करने की कोशिश करी, ऑब्वियसली कस्टमर की कंप्लेन ये थी कि तुम्हारा ब्लैक खराब है। जब हमने अपने एंड पे चेक किया तो हमारा सिमिलर बना। जब हम उसके यहाँ पे अपने रॉ मटेरियल्स लेके गए, उनके रॉ मटेरियल्स लेके गए और वहाँ से लिए और दोनों से सेम तरीके की चीज़ें बनाई, तो हमें समझ में आया कि एक MCl की वजह से ये इशू आ रहा है। तो हमने वहाँ पे आइडेंटिफाई किया था। तो मेरा ये पॉइंट यहाँ रखने का ये था कि कभी अगर ऐसा लगता है कि कोई एक पर्टिकुलर रॉ मटेरियल की वजह से भी कलर खराब हो सकता है, तो उसको आइडेंटिफाई करने के लिए आप बॉक्स फॉर्म में छोटे टेस्ट करके इसको आइडेंटिफाई कर सकते हो।
ओके सर, थैंक यू।
थैंक यू।
Thank you, Soumya. Next, we have Jagannath. Over to you, sir.
Yeah, hello, Saurabh ji, good evening. This is Dr. Jagannath Jadhav from Indo-Amines. We are not particularly performing this test for the polyurethane, but since we are in additives, like amine additives, so do you think that color is intentionally hampers with the additives like amine additives, which may be used for the foam making, like DEPA?
I don't think I know the answer to this one right now. I will note it and I'll come back to you. But मेरे experience में अभी तक ऐसा कुछ नहीं है. But still I will find it out and I'll come back to you for sure.
Okay, but somehow we understood that because of this aliphatic amine, and instead of there is using of aromatic or like BDMA or sometimes cyclic amines, like morpholin based amines, it will also stick with the colors and it will not changes the colors.
Again, colors they do have a little bit of glycols inside them, polyols inside them. So again, I am not very sure about this answer. I will definitely research on it and I'll come back to you. But right now I
Yes,
don't have an answer.
Thank you. Sure. Okay, sir.
Yeah.
Thank you, sir. Next, we have Priyank. Priyank, over to you. Priyank, please unmute yourself and ask.
Hello. Yes. Good afternoon, sir. Hello.
Good afternoon. Good
Hello.
afternoon.
Am I audible, sir?
Yeah, you are
Yes.
audible.
सर, हम लोग को यही क्वेश्चन है कि आपने आपके स्लाइड में लिखा था नो ब्लीडिंग एंड माइग्रेशन मतलब?
तो कुछ कलर्स जो होते हैं वो डाई बेस्ड होते हैं। जब वो डाई बेस्ड होते हैं तो उनमें आप अगर उसके साथ में कोई फैब्रिक रखोगे या उसके साथ में कोई दूसरा मटेरियल रेक्सीन रखा या दूसरी फोम ही रखी, तो कलर जो है वो जिस फोम, जो कलर्ड फोम है और जो दूसरी फोम है, उससे एक कलर से एक फोम से निकल के दूसरी फोम में चला जाता है। तो इस कॉन्सेप्ट को ब्लीडिंग या फिर माइग्रेशन
ओके
कहते
सर।
हैं केमिकल टर्म्स में। तो वो चीज मैंने
ओके
बताई
सर।
है कि
ओके,
पिगमेंट
थैंक यू
बेस्ड
सर।
कलर्स में जनरली ये प्रॉब्लम नहीं होती है।
ओके सर। ओके।
Yeah.
Thank you. Any other question from anyone?
Hello. Hi, Mr. Gaurav. Archana here.
Hi, Archana.
Hi. I just want to ask, is this is a liquid colorant, so is it the same as a pigment paste? As we call color concentrate is a pigment paste. So
Yes.
liquid colorants and pigment paste are the same or different?
So, what we have done over the years, we primarily used to make pigment pastes only, and still we do make pigment pastes. So right now we have tried to convert these pigment paste while maintaining the concentration, while maintaining the strength, and we have converted them into liquid by using special polyols and additives. So these are, yes, chemically these are pigment pastes, but these are converted into liquid for better usage and ease of use.
Okay, and what are the end application for the liquid colorants? I mean, it goes to multiple applications or any specific application like PU foam?
So right now on this webinar, we have really worked on the PU foams, but it goes into a lot of applications and we are working in other applications as well.
Okay, thank you. Thank you so much.
Thank you.
Thank you, Archana. Any other question?
So yeah, this is Karthik. I have one question to Gaurav.
Yes.
So may I know the pH of the system? pH.
pH is generally applicable on water-based products mostly. So these are all polyol-based or glycol-based products, and doesn't really have any pH. It is mostly in the neutral state between 5 to 7.
Thank you.
Yeah.
Hi, Gaurav ji, Rishabh here.
Hi, Rishabh ji.
Yeah, I just want to know, is it possible to develop a PU system equivalent with the density of an EVA form? Like the EVA density? Yeah.
That is a question more suitable to PU system suppliers, but yes, it is possible, and a lot of people are working in this direction. I am not authorized to say anything, but I have seen low density PU footwear there, which is equivalent density to EVA from one of the system suppliers in my last visit in the leather fair exhibition.
Okay, so
Yeah.
like you have the colors for the EVA form also, or only for the PU system?
No, we only make for PU right now. EVA uses master batch. So master batches are generally made from different kind of principle. It's an extrusion principle. We are not into master batch as of now.
Okay, so well, what I am aware of it with the current industry is like the PU systems and the PU soles are currently used, but not with the big brands like Adidas and Pumas. Nike, they are switching into the slowly into the EVA form. Even the sketches
Yes.
have fully shifted, like the upper, middle, and they have shifted it totally in the EVA. So
Yes.
how to compete with this part? Like the industries are already shrinking, so how to get into this one? Like
So
how to compete with?
their primary requirement why they are going into EVA is that the white sole should stay white. So it is a big challenge for that for them. Generally in EVA, a lot of white soles are used. And with PU, we are still not able to develop something, a PU system that stays white for as long as what EVA does. So that is one reason why PU hasn't attracted that kind of traction. But a lot of developments are on the way. And we are also developing some coatings for PU soles, especially white PU soles for it to stay white. So probably I think we will have some success in very near future. But till now, this is the main reason why people have not moved to it. Otherwise, comfort is not an issue. In fact, PU has much better properties as compared to EVA in terms of long lastingness or in terms of abrasion. So this is the main reason.
Yeah, Gaurav, hi, this is Arun. Can I say something here?
Yes, please.
Yeah, who's the gentleman who asked the question? What's the name?
Rishabh.
Hi, Rishabh. Are you from the footwear industry?
Not totally, but yeah, partially I can say. I'm in
What's
more
your
in the
background, if you
garment
can?
and less in the shoes.
Okay, my name is Arun, and I have quite a bit of experience in the PU industry, and I am the technical head of the Indian Polyurethane Association. I am the person responsible, along with my team, to run such programs for the IPUA, including webinars and technical training programs, etc. Okay, so it's a very interesting question you asked, and I will attempt to answer it. I have about more than 30 years experience in PU industry, and I've very closely worked with uh, footwear teams of a company that I used to work for, multinational company. I prefer not to name it. And I was the business head of the company as well. I have worked both in India and outside. So I have quite a bit of experience working with footwear guys and people like Nike and Adidas. I've actually been to the Nike regional technical center in South Korea and also in the Europe.
That's good.
Traditionally, it is not that now they are changing, but the chosen substrate for Nike, Adidas, and the big brands as sneakers has always been non-polyurethane. Okay, so it's been EVA. It may sometimes not just be plain EVA. It could be an alloy of various plastics, and they have their own patents around it, etc. So it's a thing that is not very well known, but they also combine polymers to make composites there. That's number one. The ingress of polyurethane generally into sports shoes has been not more than 10%. So it has never been the preferred choice for the external soles, etc. Where PU has gotten in the past, and I think it still continues to do well, is in the midsole area, where it gives that special comfort and special durability to the entire footwear construction. So it continues to be like that. Technology is obviously on the move, and one day might come that PU may get more technology oriented and could potentially provide solutions which are more attractive to guys like Nike and Adidas, and they try and use more and more of it. But as of now, I think it's the battle which is very much in the hand of competing substrates. PU is only a minuscule part of the footwear construction of these companies since 3 decades. So nothing has changed. It's still the same. I hope you answer your question.
Yeah, that's amazing. Like I was just considering, like, yeah, like, that's amazing part. Like if the PU is still developing, like I asked, like the same density, that 0.25 density that EVA is having, and if it's possible to develop in the PU, then it's an amazing part. Like it will be a great, because PU have some special, even more, more properties than EVA. So if that can be done in the PU part, then it's an amazing thing. Like,
can you please, because I think we'll outrun the time, if you can kindly give your email and mobile number to Bhavna.
Okay, sure.
We will send specific information. We'll send specific information on elastomer grades or footwear grades that are closer to 0.25 density. I'll send it to you.
That's amazing. If that can be done, it's amazing. Can I have
sure.
Where to share that number? Like, can you just let me know where to share that number in the chat?
Yeah, in the chat. I mean, Bhavna will pick it up. Bhavna, can you pick it up?
Yeah, I can. And it's the same ID wherein you have sent the registration email, administration@ipua.in.
Okay, well, I have shared the number in the chat itself.
Sure.
Okay, great. So we'll pick it up and we'll send the required information to you. Don't worry. Take care.
Thanks a lot. Yeah, it was a great, amazing.
No problem. Pleasure.
Yeah.
So there are some questions in chat. Can we do that also as well?
Yes,
please
sure.
tend to all the questions.
Yeah. So Vishal has asked, are these pigments applicable for hot cast elastomers? Yes, we do have pigments for hot cast elastomers. They require high performance pigments, as already mentioned in the question answers, because of the high heat resistance. So we have pigments that are applicable for hot cast elastomers. If you need anything, please contact us for that. Then second is, fillers are being used in color pigments, specifically if color pigments is used in integral skin foam. No, nobody uses fillers. I don't think fillers are being used in color pigments. At least I have not come across that, because there is no space. You have to make the product stay liquid as well. You have to put so much of pigment inside also. So if you add further filler into it, it becomes a lot challenging for you to reduce the viscosity. So, and it again reduces the color intensity. So fillers, I don't think are used in the color pigments. And if fillers are used, then what particle size and what are implications on machines? So I don't think fillers are used into the color industry. So these are the two questions. If anybody else, any other question, please feel free to ask.
Hello, sir. Good afternoon.
Good afternoon.
Sir, my concern is in foaming application, when I mix two primary colors like red and yellow,
Yes.
जैसे कि ऑरेंज साइड के लिए हमने येलो और रेड को मिक्स कर दिया, बट मेरा तो फाइनल एप्लीकेशन में जो स्टॉचिंग की प्रॉब्लम आती है,
ओके,
तो इसका कैसे सॉल्व किया जाए?
ऐसा होता है, ये आपने बिल्कुल सही क्वेश्चन पूछा. सो बेसिकली व्हेन यू वांट टू मिक्स टू कलर, जब आप दो कलर को मिलाकर तीसरा कलर बनाना चाह रहे हो, तो वो दोनों कलर एक दूसरे के साथ कंपैटिबल होना बहुत जरूरी है. तो हमने भी जब प्राइमरी कलर्स बनाए, तो उसके लिए हमारा पिगमेंट सिलेक्शन बहुत इंपॉर्टेंट हो गया, क्योंकि हम उन पिगमेंट्स को एक दूसरे के साथ चेक करते हैं कि वो एक दूसरे के साथ कंपैटिबल है कि नहीं है. आपके केस में रीजन यही रहा होगा कि रेड और येलो सेपरेटली चलने के लिए तो बिल्कुल ठीक है, बट साथ में चलने की वजह से उनको ये प्रॉब्लम हुई है. तो आप अपने कलर सप्लायर से ऐसी चीज मांगे या हमसे आप हमें कांटेक्ट करें, हम आपको ऐसे पिगमेंट्स देंगे जिनको आप मिक्स करेंगे तो आपस में स्कॉचिंग नहीं आएगी.
बट सर ऐसे कुछ एडिटिव्स या फिर किसी बाइंडर कुछ मिल जाए ताकि अपने रिसोर्स से इसको डाल के कर सके?
नहीं, ये दो अलग अलग पिगमेंट्स का आपस में एक दूसरे के खिलाफ नफरत सी है, जिसकी वजह से वो आपस में ये प्रॉब्लम क्रिएट कर रहे हैं. ये एडिटिव से सॉल्व नहीं हो पाती, तो आपको कंपैटिबल पिगमेंट ढूंढने ही पड़ेंगे.
ओके सर.
Yeah, we have received two more questions in the chat box.
Is there any shelf life for color pigments? How much stable is the polyol? So, how much? So shelf life for color, what we suggest is around 1 year, and after 1 year, it is not like the color is unusable, but it will not stay in the same viscosity zone. The specification that we have given you, it will move away from that. So if it is workable, you can use it. If it is not workable, then you'll have to discard it. And how much stable it is in the polyol. So our colors are completely stable in the polyol. And if you mix it, can be a tendency for phase separation if you mix it at your end. If we give you mixture, then there is no tendency for phase separation. But at your end, if you do it, there can be a tendency for phase separation. So you have to again mix it before usage.
Thanks, Gaurav. Any other question from anyone? I think there are no further questions. So thank you all for attending today's webinar, and a special thanks to Gaurav for sharing such valuable insights and for your precious time. Thank you. Have a great day.
Thank you all. Thank you all for coming and giving me your time. Thank you so much. It was my pleasure.
Thank you, sir.
Thank you.